discuss about factors also.
Affecting evaporation?
Yeah, ma'am.
Okay. And any problem in that?
No, ma'am.
Okay. Lokia, could you please quickly explain me some of the factors that affect the rate of evaporation?
What, ma'am?
Could you please quickly explain me some of the factors which affect the rate of evaporation?
Humidity,
Mm-hmm.
wind speed, temperature, and surface area.
Okay. Sulman, is that correct?
Yes, ma'am.
That is correct. Can you tell me how does humidity affect the rate of evaporation? Just tell me the relation between humidity and the rate of evaporation. By relationship, I mean, can you tell me if humidity is more, will rate of evaporation be more or less? Something like this.
Ma'am, if the humidity will be more, rate of evaporation will decrease, and if
Okay.
humidity is less, rate of evaporation will increase.
Very good. Very good. Loki, can you explain me what is the relationship between the surface area and the rate of evaporation?
When surface area is more, the rate of evaporation will be increased because more the surface area, more the evaporation.
Wonderful. That's fine. And what's the relationship with temperature, Lokia?
Temperature,
And evaporation, rate of evaporation?
more the temperature, the rate of evaporation increases.
Wonderful. More the temperature, the rate of evaporation increases. Suleiman, but can you explain me how does the wind affect the rate of evaporation?
Ma'am, if there is increase in wind speed, the rate of evaporation increases.
Very good. It increases because obviously it takes away the water vapor particles in the air, therefore decreases the number of water vapor particles in the air, therefore increases the rate of evaporation.
Yeah, ma'am.
Understood? Okay. And also very important, we discussed some of the major differences between boiling and evaporation. Yes?
Yes, ma'am.
Yes. So that's fine. Now coming on to the next topic. We have to discuss some of the daily life examples of evaporation. We discussed that evaporation is a natural process, whereas boiling is not a natural process. Okay. And which among them produces a cooling effect, boiling or evaporation?
Evaporation.
Very good. Lokia?
Evaporation.
Bethel, do you understand some of this better?
Yes, ma'am.
Now we have to start with the daily life examples of evaporation. Quickly. I think that day we discussed some of them. You people told me the drying of clothes and something like that, right? So that is all example of evaporation. So I would want to start with one example, Bacho. Is it visible? I don't think it is visible. Just a second. Is it visible now? Yes, I think it should be.
Yes, ma'am.
Okay, fine. Now, one very important thing that all of us must have done, and obviously all of us have also observed, is that what happens in the kitchen. When we heat a container, let's say we have a container, the container gets heated. Okay. Definitely we cannot touch it directly because it's very hot. Okay. At times, to make it cooler and to handle it normally, what do? We actually put it under the running water. Do we do that or not?
Yes,
We
ma'am.
put hot containers under the running water. Why do we do that? Any idea? Just think and then answer. Okay. Yes. We keep the hot containers, the containers which have been heated, under running water. Why? Acha, leave why. Tell me what happens after that. Does that container become cooler? Can we handle it after that? I think we can, right?
Yeah, ma'am.
Yes, we can. So we know what we are doing. We know what is the effect of that. That means the container gets cooled down. Why is that container getting cooled down if we are keeping it under the running water?
Ma'am, there is a process of evaporation.
Okay, wonderful. Process of evaporation happens there. Can you explain me, Suleiman, beta? How does that happen?
Ma'am, if we put water in the container, the water changes into vapor. So it will gain some energy in the atmosphere. So that's why the container becomes
Okay,
cooler.
wonderful. I get your point. Wonderfully done. So I think your concept is clear. I'll actually explain this further. But look here, any point to this, beta? Any point that he has missed on this? Yes, beta? No worries. Bethel, any point?
No, ma'am.
Fine. See, but Suleiman, wonderfully explained. I would just like to explain you like a bit further. What happens? Let's say, beta, we have a container like this, and obviously it is heated. Yes, it is heated. So it has high temperature. Yes, definitely high temperature means high energy. That high energy, this high energy is with the container. Okay, it is with the container. Now what happens, beta? We have running water here. Okay, we have running water here. This running water, when it actually falls down on this container, let's say we have 10 particles here in the running water. Okay, some of the particles from that running water, will actually acquire this energy from this high temperature or this high energy which is in there in the container, and some of the particles will actually get evaporated. That means some of the particles will change to the gaseous state below their boiling point. Below their boiling point. Why? Because they are acquiring the energy from the surrounding. What is the surrounding here? Container. And always remember, the surrounding, whatever the surrounding is, which actually transfers the energy to the water particles. Okay, that is the surrounding which will have the cooling effect. You getting it? As in this case, the energy is supplied by which container? The container which is already heated, right? This is the surrounding for water here. So after evaporation has taken place, this container which was the surrounding will be cooled down. Is it clear? In case the energy is supplied from the surrounding, which is atmosphere. Okay, in case the energy is supplied from the surrounding, which is atmosphere, so the cooling effect will be experienced by the atmosphere also. Is it clear? In case the energy is supplied by the palm, okay, so then in the surrounding becomes our palm, the cooling effect will be taking place for the palm only. Is it clear? Not for the atmosphere. I hope this point is clear. Fine. So now what happens? Evaporation takes place here. Some of the particles, not all, some of the particles which will acquire higher kinetic energy. Yes, due to the interaction with the surrounding, in this case, the surrounding is the container, will actually transition to the gaseous state. When they transition to the gaseous state at a temperature below their boiling point, therefore evaporation happens. If evaporation happens, definitely a cooling effect will be seen on the surrounding. Here, that is the container. I hope this point is clear.
Yes,
Any problem in this, Bethel, Lokia?
No, ma'am.
Fine. Moving on to the next example, Bacho. Moving on to the next example. Why do we generally prefer cotton clothes in summer? I think we have discussed this example in the last class, yes?
yes, ma'am.
Cotton clothes is a good absorber of water.
It is good absorber of
Ma'am,
water. Actually, it helps. Yes, Solomon.
ma'am, the cotton clothes absorbs the sweat, and it
See,
evaporates in the atmosphere.
wonderful. Both of you well done. See what happens. Actually, we cannot say that the cotton clothes are good absorber of sweat. No. Actually, cotton clothes are very breathable fabric. That means they allow for the process of evaporation to take place very smoothly and easily. Yes, they allow for the process of evaporation that is on our skin, which is called as perspiration. I think we have discussed this. Perspiration, yes.
Yes, ma'am. No, ma'am.
Okay, but I will discuss this. Perspiration. Perspiration, this is actually a biological process that happens on our bodies, right? What happens? We sweat, okay? We sweat. The sweat is actually evaporated. The sweat is evaporated, and the sweat actually takes the energy. Sweat is in what form? Liquid form, yes. Sweat actually takes the energy from our bodies. Therefore, our bodies become the surrounding here, yes. Therefore, our bodies have a cooling effect. Okay, so our bodies have a cooling effect. Is it clear, Bacho?
Ma'am,
Because of
ma'am,
yes,
ma'am, can I explain once more?
yes. What happens? We sweat. Okay, whenever the temperature is higher, because our bodies have a tendency to maintain a fixed temperature. Our bodies function at a fixed temperature. As soon as the temperature goes higher because of the high temperature outside, whatever is the reason, okay, what our bodies tend to do is that they tend to actually take the temperature back at the original temperature, okay, which is fixed for our bodies. So in order to do that, what happens? We sweat. And as soon as we sweat, the process of perspiration happens. What is perspiration? See, this is liquid sweat. Okay. Liquid sweat, some of the particles in this liquid sweat absorb the energy from our bodies, which are already very high on energy. Yes. As soon as that high energy from our bodies is transferred to this liquid particles, okay, they actually evaporate.
Yes, ma'am. Yeah,
And
ma'am.
what our bodies are losing that heat energy because they are giving it to the liquid particles.
Yeah,
Therefore,
ma'am.
our bodies experience a cooling effect. This process to maintain the temperature of our body, and we sweat in order to maintain the temperature of our body, is called as perspiration. Is it clear?
Yes, ma'am.
Yes.
Okay. Now what happens if we wear a fabric which is not breathable? Not breathable means evaporation process will not happen very easily. You getting it? You getting it?
Yeah,
Because
ma'am.
why it
Yes,
not
ma'am.
very easily? Because those particles do not have very small pores in between. Natural fibers like cotton have pores in between. Okay, very small pores. Okay, so that allows for the vapors to escape very easily. If we are wearing synthetic clothes which do not have pores in between, the vapors, the water vapors, are not escaped very easily. Is it clear? If they are not escaping, obviously they will not. If process of evaporation does not happen, and therefore temperature does not decrease. Therefore, cooling effect does not take place. Clear, bachcho?
Yeah,
Yes.
ma'am.
Any
Yes,
problem?
ma'am.
No, ma'am.
No. Fine.
No, ma'am.
Third example, bachcho. Third example. We often use matka, earthen pots, and that is to keep the water cool. Why?
Ma'am, evaporation occurs.
Evaporation occurs. Wonderful, that happens. But how and why does it happen? Earthen pots make water cooler.
There is a
Yes, beta. Please speak.
there are some pores in and that matka.
Wonderful. So let's say, please bear with my drawing. Let's say we have a matka like this, okay? Now, because obviously it is made up of something which is very organic, yes? Now, what happens? It has
ma'am.
very small pores in between, all throughout. Let's say we pour in water, okay? Let's say we pour in water, fine? Now, this water will be having some temperature, yes or no?
Yes.
This water will be having some temperature. Some of these particles through this high energy will actually evaporate, yes or no? Through these pores.
Yes, ma'am.
Don't you think the temperature of this water will decrease, Suleiman? Yes.
Yes,
Suleiman, but
ma'am.
you are busy in something. What are you doing?
No, ma'am. I was writing something in chat.
Okay. Okay. So the temperature decreases. The temperature of this water decreases. Obviously, the water will experience a cooling effect. Is it clear, bachcho?
Yes, ma'am.
Fine. What's the next
Yes,
example?
ma'am.
What's the next example? Yes. Mm-hmm. Why do we sip tea from saucers in order to have it quickly? What happens in that?
Ma'am, saucer
Why are we
have more surface area.
wonderful? Saucers have a greater surface area, which increases the rate of
Evaporation.
evaporation. Bethel and Lokya, better please answer me. Lokya, you answer me.
Evaporation.
If rate of evaporation increases, okay, how is that helping us? Only Lokya will answer. Okay. Bethel and Lokya, are you both twinning today? Both wearing pink, huh? Did both of you decide it earlier? Yes. Lokya,
Ma'am, can you repeat the question?
I'm saying we are having a tea from a mug, okay? Else we are having it from saucer, okay? Why are we able to sip tea from the saucer very easily?
Lift.
Sip, sip to drink, to take in.
Because it has more surface area.
Yeah, but my question is, how does that more surface area help us? What is the role played by this greater surface area here? Bethel, any answer, beta?
Yes.
Yes, any answer?
The
Beta?
if the surface area is more than the evaporation increase, so it cools.
Yeah. What happens if the evaporation rate is more? What will cool down?
So the liquid inside the saucer.
Yes, the liquid inside the saucer will actually cool down very quickly. Why? Because in this case, the rate of evaporation is more, therefore cooling effect will take place very quickly. Fine. Lokya, understood, beta?
Yes, ma'am.
Yes, ma'am.
Lokya, you are not very interactive, huh? Either you are not liking it or there's some other problem. Fine. Next example, beta. We all have seen the desert coolers, right? Desert coolers, you understand, in India, it's a big thing,
Yes,
very important. Okay. How does that actually give you that cooling effect? Can anyone explain me?
Yes, ma'am. The water
Yeah.
inside the desert cooler makes it evaporate.
What is evaporated?
Cooling effect. No,
I'm getting your point. Yes.
so the
We,
energy.
yeah, generally to have that cooling effect, we put in water inside. Yes.
Yes, ma'am.
Good. Suleiman and Lokha, any point to this, bacho? Okay. Let's
ma'am.
understand. Yes.
Ma'am, the hot dry air passes through desert cooler.
Very good. Very good. See, let's try to understand. Please bear with my drawings again. Let's assume this is a cooler. Okay. You must have seen there are actually something very organic which is arranged here on the sides of the cooler. Yes. And that is a very breathable material. Okay. That is very breathable material. Now what happens? Okay. Let's assume, okay, let's assume we have water in this. Okay. Let's assume this is the water. Fine. Now, obviously, there is air which is obviously with a very high temperature. Okay. The air enters the cooler with a very high temperature. Fine. As soon as it enters the cooler, obviously these water particles will interact with these air particles, yes or no? Yes.
Yes, ma'am.
As soon as they interact with these air particles, the air particles transfer their energy to some of the water particles. Fine. As soon as that happens, clearly the temperature of the air will decrease. Fine.
Yes, ma'am.
Therefore, the air which is coming out has a lower temperature. And what happens to those water molecules which have actually gained the energy? They evaporate. That is, they change to the gaseous state. And how are they escaped from the cooler? We have pores here on the sides of the cooler. Is it clear? Lokya,
Yes, ma'am.
Yes,
Beta, should I explain again?
no, ma'am.
Okay, fine.
Ma'am,
So I hope, yes, Sulman.
ma'am, can I explain once more?
This point, cooler,
Yeah, ma'am.
fine. Let's see. We have air here which is entering the cooler. Okay, that has high temperature. Okay,
Okay,
clearly high energy.
yeah,
Yes or
ma'am.
no, beta? Okay. As soon as it enters the cooler, we have water molecules here. Right?
Yes,
The
ma'am.
surface water molecules will be able to interact with these air molecules here. Yes or no?
Yes, ma'am.
Remember from the last class that as soon as the interaction happens, there is change of energy. There is an exchange of energy between the particles. Yes.
Yeah, ma'am.
So air molecules which have high energy will actually transform that energy to what? The water molecules. Yes.
Yes, ma'am.
Okay. So the air molecules will actually lose the energy. As soon as the air molecules lose the energy, obviously the temperature will drop down for the air molecule. That means
Yes,
the air
ma'am.
which entered as very dry and hot air actually becomes very cool air. Yes.
Yes, ma'am.
So that cool air is actually given out here. Fine.
Yeah, ma'am.
Now the water molecules which actually absorb the energy from the air particles, okay. Obviously some of them would have absorbed. Those particles will change to the gaseous state
Yes, ma'am.
because they have absorbed the energy, therefore their kinetic energy will increase. Yes. Therefore
Yes,
they
ma'am.
will be transitioning to the gaseous state. As soon as they transition to the gaseous state, obviously since they become the gaseous, if they are in the gaseous state now, they would escape from the cooler. Yes.
Yes, ma'am.
And how they do this? We have actually breathable fabric inside the cooler. Is it clear?
Yes, ma'am. Understood.
Any problem here? Bethel and Lokya beta.
No, ma'am.
No,
Fine.
ma'am.
Lokya, Bethel, and Suleiman. One more example. I don't know, this is the fifth or the fourth one. When we actually let's say we have a container here, okay? It was kept in the fridge. It was kept in the fridge. As soon as we take it out and keep it at the room temperature, mind it, room temperature, okay? Room temperature, let's say 25 degrees Celsius, okay? We actually see some water droplets around the on the walls of the container? Yes or no?
Yes, ma'am.
Why does that happen, beta?
Ma'am.
Yes.
Ma'am, if we keep that object in room temperature, like there is process of melting, so that's why like water droplets are coming.
Process of melting takes place, right? So assuming, okay,
Ma'am,
that's, I get your point.
Ma'am,
Just a
heat
second.
energy is the heat energy. Like,
Yeah,
it's
just a
melting.
second. Yeah, just a second, Bachcho. Suleiman, as far as I am able to understand your point, let's say we had something in here, okay? It's in the container, okay?
Yeah, ma'am.
So obviously, let's say if since it is in the freezer or the fridge, it is in the solid state, something like this, yes?
Yeah,
As
ma'am.
soon as we
yes,
keep
ma'am.
it on the in the room temperature, you are saying that the material which was there inside the container will melt.
No, ma'am. First this one outside it will start melting because
What is going to melt? The container walls will melt.
no, ma'am.
And
Outside container
Ma'am,
the water droplet will come because it is starting melting. Afterwards, the solid will melt.
I get your point. You are saying the
ma'am,
particles which are there on the walls of the container, they are melting. Yes,
Yeah, ma'am. Outside.
fine. I get it. Yes, Bethel.
ma'am, the air present in the surrounding will contact to the container the code. So the what?
Yes, yes. You got stuck in between, but I get your point. Very well done. Lokya?
um, when the air touches the cool container, we see because the water vapor
Mhm.
cools down and it changes into tiny droplets.
But okay, well done. To all three of you, one question. One question. Why? How is the air particles of a concern here? We are taking the container outside, right? Air was there before also, it was there afterwards also. Why are the air particles changing to the liquid state now? Bethel and Lokia,
The
I think both of you said
contact
this, that the air particle. So yes, if it is contacting, why is the air particles changing to the liquid state, bachcho?
it loses energy.
To what?
The liquid gas, liquid state.
It loses energy to the liquid state. What's the liquid state here?
That
Huh? See,
that
look here, bachcho. Look here, all three of you. Suleiman, Bethel and look here, bachcho. Focus. Let's say, beta, we have a container here, okay? It was kept in the freezer or in the fridge, okay? So it has a very low temperature, fine? It has a low temperature, okay? What happens, beta, as soon as we keep it outside, let's say at room temperature, okay, bachcho? What will happen? Because it is at the room temperature, so it will, the particles here, the particles inside this, they will want to attain the energy which can bring them at 25 degrees Celsius, yes or no?
yes, ma'am.
But you
Yes, ma'am.
agreed, okay? The particles which were cooler, now they have been brought to the 25 degrees Celsius temperature. Don't you think the particles will want to attain a temperature of 25 degrees Celsius, yes or no? Why? Because they want to gain the energy for that, yes or no?
Yes.
Do
Yes,
you get
ma'am.
that? Now the particles they want to gain the energy. From where will they gain the energy? The air particles which are in the gaseous state, clearly they have more energy, yes or no?
Yes, ma'am.
These
Yes, ma'am.
particles which are inside the container, okay, these gaseous particles actually transfer the energy to these particles which are inside the container. We are not concerned with that state. Whatever state it is, the particles inside the container, they will just want to gain energy so that they are at a temperature of 25 degrees Celsius because they have been kept at that temperature. Is it clear?
Yes, ma'am.
Now what happens? The gaseous
Yes, ma'am.
particles lose the energy. Okay. Now the gaseous particles lose the energy. Obviously, the gaseous particles near this container will be losing the energy. They will be transferring the energy. Okay. As soon as the gaseous particles near the water container lose the energy to the particles of the water container, the gaseous particles, since they have lost the energy, they will change to the liquid state. Okay. They will change to the liquid state. It is very clear. It is a process of cooling for the gaseous state. And how are they cooling? By transferring their energy to the particles of the container. Now here the water particles will be there. And why are they here on the walls of the container? Because the gaseous particles which were near to the walls of the container, only those particles transfer the energy. Therefore, only those particles have transitioned to the liquid state and only those particles are there on the walls of the container in the liquid state. Is it clear or should I repeat again?
Clear, ma'am.
Wonderful. Bethel,
Yes, ma'am. Clear.
Lokia, any hesitation, please ask me. Okay. You should not actually hesitate because the two of them are clear with this concept. Any problem?
No, ma'am.
Fine. Wonderful. So yes. Any other example, Bachu, that you would want to discuss and or is left? Any other example?
Nail polish remover.
Yes, nail polish remover. Okay, good. Now, till now, we have been generally talking about the cases in which water is getting evaporated. Yes? Yes, Suleiman.
Yes, ma'am.
No, ma'am, nothing. Ma'am,
You raised
afterwards I
your
will
hand.
say.
Okay, fine. Just actually tell me that you want to say something. I often forget that. No worries. What happens till now? We have been taking the case of water particles. Yes? The water was in the liquid state. The water changes to the gaseous state. Fine. Now let's see the example of a nail polish remover. Nail polish remover is an organic substance which is acetone. Okay. Acetone is an organic compound. Okay. It is different from water. It's a different compound. So can I say it's a different matter? If it's a different matter, obviously the boiling point and the melting point will be different in this case. Obviously the intermolecular forces between these particles will be different. Yes or no? Therefore, the energy required to change it to the gaseous state or the liquid state will also be different than water.
Yes,
Please say
ma'am.
yes or no.
Yes, ma'am.
Yes.
Bethel?
Yes, ma'am.
Yes or no? Fine. Now see what happens. As soon as we actually apply the nail polish remover, let's say we have a nail here. Okay. Please bear with my drawings again. Okay. We apply the nail polish remover. What happens? The nail polish actually gets mixed with this acetone. Okay, which is a nail polish remover. Okay. And this acetone actually evaporates. Okay. It changes to the what state? The gaseous state. Let me just tell you, even the boiling point of acetone is very low. Okay. It can catch fire very easily. So an evaporation takes place below the boiling point. So imagine how quickly the evaporation will happen. Yes or no? So because the acetone has a very low melting point, it can actually change to the gaseous state very quickly, very easily at a very low temperature also. That is why as soon as we apply the nail polish remover, that is acetone, the acetone evaporates, also taking with it the compounds of the nail polish. Is it clear?
Yes, ma'am.
Yes, ma'am.
Second example related to this is something that we actually put acetone on our palms, yes, and then we have a cooling effect. Why do we have a cooling effect? Because acetone on our hand, okay, as soon as the particles of acetone are there on our palm, the palm actually transfers some of the energy to the acetone. The acetone evaporates, and because the palm has transferred the energy, the palm has lost some energy, therefore the palm experiences a cooling effect. Is it clear, Bachu? Yes, Suleiman.
Yes, ma'am.
Ma'am, the particles of acetone, they will gain some energy from our palm,
Yes,
and it evaporates.
very good. Exactly, that is what happens. I hope this is clear to all three of you.
Yes, ma'am.
Okay.
Yes,
Let me
ma'am.
just quickly see if there's any other example that I
Ma'am,
would want
another
to discuss.
example, ma'am.
Yes, 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 yes.
Ma'am, after a hot sunny day, people sprinkle water on the roof.
Exactly. That's very good. People sprinkle water on the seats, yes, or their vehicles. We do not put water bottles or we do not put full containers, water full of containers on the seats to make it cool. Yes. What do? We just sprinkle the water. Why do we do this? Because the particles of water are on the surface then. Yes. Those surface particles are actually able to absorb the energy from the surrounding. That surrounding is what here? The seat, which is already very hot, okay, which already has a very high temperature. The seat transfers the energy to the water particles, which are on the surface only. Therefore, the particles evaporate, taking energy from the seat. Therefore, the seat experiences a cooling effect. Yes, Suleiman.
Ma'am, it will gain some energy of the surface of the roof, so it evaporates, so it makes the cooling effect.
Exactly. This is what happens. Wonderful. I think this is clear. Good, Suleiman. Good example.
Yes, ma'am.
Yes, ma'am.
Thank you,
Lokya,
ma'am.
Bethel, any problem, Acho?
No,
No,
ma'am.
ma'am.
I hope you have written this if you wanted to. Do
Ma'am,
I
is
need to
there
repeat
in
it?
the NCRT?
Yeah, it's there in the NCRT. Yeah. But you please always remember one thing, try to write the points whenever you are trying to learn something. As in learn in the sense, you are trying to understand something, okay? Try to write it in your own words. Once you have understood that in your own words, then obviously refer to the books words of the book, okay? In your case, NCRT. Because then obviously you have a proper answer to write it in the exam. But before that, try to once write it in your own words, okay? That will really help you to understand things better, okay? That is very important. Now, any other point, Bacho, in this chapter that you want to discuss? Else, I will move on to some of the important points for this chapter. Quickly go through it, please. I am giving you a minute. Please go through it.
Okay, ma'am.
Yeah.
Ma'am,
Yes.
ma'am, one other example, like one small, this one. In an open vessel, the liquid keeps on evaporating.
Yes, because they keep on gaining energy from the atmospheric particles. Therefore,
Yeah,
they
ma'am.
keep on evaporating. If the container is closed, okay, obviously they will not be able to interact with the atmospheric particles. Therefore, no increase in the kinetic energy takes place. Fine.
Ma'am,
Yes.
ma'am, rate of evaporation on aqueous solution, the rate of evaporation will decrease.
Yes. The point I wanted to discuss here. Good. I was about to discuss that, but before that, any other problem
No, ma'am.
that I would want to discuss at last? Yes. But to tell me, have I discussed that point wherein why does ice float on water?
Ma'am,
Yes.
ma'am, water expands on cooling.
Here
No,
let's say the temperature is constant.
no, ma'am, sorry. Water expands on freezing.
Heating.
Sorry, water expands on heating.
Yeah.
And that is,
But I'm saying the condition is the temperature is constant. Okay, no temperature change is taking place then. I think I've not discussed this. Let's quickly discuss this. Okay.
Which
okay,
one,
ma'am.
So
ma'am?
what happens? Yes, yes. Who's saying that? Yes, look here.
I think you discussed it, ma'am.
No worries. I think I've not discussed this with them. Let's quickly discuss it. No worries. Okay. Ice, which is a solid. Okay. Ice is a solid, and liquid water. Now, if I'm able to recall the properties of solid and the liquid state, clearly the solid states, they have a higher density. Yes. The liquid state has a lower density than the solid state. Now, from that rule, the solid, which is ice, should actually sink down in the water because it has higher density. I hope you are able to imagine that what is density.
Yeah,
Yes, I
ma'am.
think I've discussed it, right? Now, but that does not happen. Instead, what happens? The ice, which is solid, actually floats on water. Now, this can only happen in a case when ice has low density than water. Okay. How is that possible? Although ice is a solid. See what happens. Ice, which is a solid, has some structural differences. What is that structural differences? Let's try to understand. See. Ice actually has some air spaces in between its particles. Okay. Okay, bache? Between its particles. Therefore, overall, the density for ice, which is a solid, actually gets decreased from the overall density of water, which is a liquid water. Okay. Therefore, ice actually floats on water and does not sink into the water. Yes, Lokia, you want to say something?
No, ma'am.
Fine. Mohammad, Suleiman, and Bethel, is it clear, bacho? Because of the structural the arrangement, okay. In case of ice, ice floats on water. Clear, bacho?
Yes, ma'am.
One very important point. Moving on to the next point. Should I start? I think Suleiman is writing. Bethel, have you written it down, or you don't want to? That's fine. Whatever is okay with you.
Finish,
Okay.
ma'am. Ma'am, clear.
That's fine. See, one very important point here, Bachu. Can you tell me the boiling point of water?
100 degrees Celsius.
100
100
degrees
degrees.
Celsius.
Fine. That is 100 degrees Celsius. Let's say this is for pure water. Yes or no?
Yes,
This
ma'am.
is for pure water. Let's say I have mixed something in pure water. Okay. Let's say I have mixed something in pure water. And Suleiman Bacha, I want you to not answer this question. Okay, here. Because I know that you know. No worries.
Okay, ma'am.
Yeah. Let's say I have mixed something here in pure water. What will be the effect of this addition of something else into pure water on its melting, on its boiling point? Will the boiling point remain same? Will the boiling point increase? Or will the boiling point decrease? Just think
Can
and
you
then let me
repeat
know.
it?
Yes, I repeat it. See, I'm saying we have pure water. Obviously, if it is pure water, the temperature at which that pure water is transitioning to the gaseous state is 100 degrees Celsius. Yes or no? Right?
Yes, ma'am.
That means the boiling point of that pure water is 100 degrees Celsius. Now we have a second scenario. We add something into that water. Okay. We add any other pure substance in that water. Okay. Now that becomes a mixture of two substances, water and something else, right? Now the boiling point of that mixture or of that solution will remain same or will it change? I mean, will it increase or will it decrease or will it remain same? No worries. Don't actually worry. Yes, Lokya beta. Any point that's coming to your mind, I would want you to share here. Please.
It will change.
It will change. Very good. Can you tell me in what direction will it change? Will it increase or will it decrease? Very good, by the way. Lokya, very well done. Yes. Okay, no worries. Lokya, can you just give me any point that you have in your mind as to why will it change? I'm not concerned whether will it decrease or whether will it increase. Okay. Why do you think will that change? Yes.
Ma'am, can you again repeat the question?
Yes, I repeat my question. We have pure water, which is actually getting boiled at 100 degrees Celsius. That means the boiling point of water, pure water, is 100 degrees Celsius. I have mixed something in that water. Now that becomes different from pure water. I think that is very clear. Yes. So now will that have boiling point as 100 degrees Celsius only, or will that boiling point change for that mixture? Okay.
It will increase.
It will increase. Why will it increase? Can you tell me? Let me just tell you that answer is very correct and very well done. But please, any point that would explain this answer. Okay. What made you say it will increase? Tukka, ma'am, tukka, huh? You know tukka? Guesswork, guesswork. We are very pro at taking a guess, huh?
No, ma'am, it's not a guess.
Just kidding. No worries. Don't take it so seriously. That's fine. Yes. See, what happens, because we are short on time. Let's quickly discuss it. What happens? Let's say, bache, we have water, which is obviously pure water here. Now, because let's say we have 100 molecules of only water. We have a container here. We have 100 molecules of water. Is that okay? Because it's pure water, obviously the boiling point for this water is 100 degrees Celsius. Fine? Clear? Let's say we have any other substance whose name is A. Okay? Let's say. Now, just ignore this part right now. Okay? We are just concerned with the A substance. Okay? The A has a boiling point of, let's say, 78 degrees Celsius. That means if there are all the particles of substance A, they will actually change to the gaseous state at 78 degrees Celsius. Is this point understood? Yes or no?
Yes, ma'am.
Now what happens? If I mix them, okay. Now there's a container also where there's water particles in the green, in the black color, and there's also A particles in the green color. Fine. Okay, bache? Something like this. Can you tell me what effect will it have on the boiling point? I'll give you one example. I'll just give you one example, okay? If I mix water and if I mix salt, will the taste be different or will it not be different?
It will be different.
It is
I
different.
think overall, yes, overall it will be a mixture of the taste of the water and the salt. If something like that exists, yes? Yes or no? Yes or no, bache? Yes or no? Please say yes or no. Say, see what happens. Look here. Look here, please come on the camera. It's fine. Look here, what happens? Because these water particles here, let's say we have 3 water particles which are pure water, okay? They have their boiling point at 100 degrees Celsius. There we also have 3 particles which have their boiling point at 78 degrees Celsius, okay? So overall, don't you think it will be a mixture of the boiling points of all of them? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Therefore, that is the reason if we mix something into the water, the boiling point of water will change. Is it clear?
Yes, ma'am.
Is it understood? Clearly understood? Yes or no? And I'm giving you one question. You will think over it and then you will tell me. Can it only increase or can it also decrease if we have mixed something into pure water? Okay. That you will tell me after thinking. And hopefully, no AI will be taken help of. Okay. Okay. Yes or no? Yes, bacho. Chat GPT will not be taken help of. Okay. Chat GPT will not have to answer this one. I hope the answer will come from your thinking, from your mind. Okay. Lokia, please answer.
Yes, ma'am.
Yeah. Yes, Suleiman. Any answer to this?
Ma'am, it will increase the. It will not decrease. It will increase
Okay.
the this one boiling point.
Fine. That you will think upon, all 3 of you. Okay. He has given his answer. Suleiman, you will also think over it. Bethel and Lokha, you will also think over it. Okay.
Okay.
Okay, fine. Now,
Yeah.
quickly, 2 very important points here, but that's left in this chapter. We have studied 3 states of matter. Yes. We have studied 3 states of matter that are there present in our day-to-day life. Okay. That's it. There are also 2 other states of matter which do not exist at day-to-day normal life. Okay. They have very different conditions. First is plasma. Okay. Second is Bose-Einstein condensate. Yes, Suleiman.
Yeah, ma'am. Ma'am,
Fine.
ma'am, in my school I didn't study about this plasma and Bose. This one Bose Einstein condensate.
Condensate.
Yeah, ma'am.
Yes.
I didn't study, ma'am.
No worries. Actually, it's given in a very small box at the last NCRT first chapter. Okay. So because we are discussing NCRT, we have to discuss each and every point. Okay. Just a very brief discussion about it. What are they? Okay.
Okay,
So
ma'am.
see what happens. Plasma is a state. Plasma is a state which exists at a very high temperature. Okay. That's extremely high. And that generally happens in the space. Okay. The stars, the sun, all of them, they are in the plasma state. Clear?
Yes.
Because they are so high. Actually, what happens? The inert gases, inert gases, the gases which are not very reactive. Yes. At this
Ma'am,
temperature,
helium.
yes, helium, argon, neon, all of them, very well done. So when they are in the plasma state, okay, when they are in the plasma state, the inert gases also get ionized. What happens? They get ionized. By ionized means they also start reacting. In simple terms, that's the point. Okay. Because the temperature is so high in this state. Is it clear? That's the only point that you have to understand in this case. Fine. Examples: sun, stars, all of them. Also, you must have seen the neon lamps, all of that around us. Nowadays, it's increasing. Yes. That also happens because of the plasma state. Neon, which is a very inert gas, actually gives off that color because it gets ionized because it's in the plasma state. Fine. Yes or no?
Yes, ma'am.
Look here. Please respond.
Yes, ma'am.
Yes, ma'am. I'm done, ma'am. Please finish it. Last point. The second is Bose-Einstein condensate. Okay. Bose-Einstein condensate is a state which happens when we have decreased the density to a very, 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 very low density, and therefore the temperature decreases too much. Okay. In simple words, it's a very, very, very cool state. Okay. The temperature is very low in this state. Fine. Yes or no, macho?
Yes, ma'am.
Ma'am.
Ma'am, Bose-Einstein condensate, they are very cold. Like they are cold.
Yes. Yeah. So generally, superconductors, we have something called as superconductors. They are actually operated in this state because they need a very low temperature. Okay. So
Yes.
what happens, bacho? The density is actually decreased to 1/10,000th of the air density. Okay. 1/10,000th of the air density. Therefore, the temperature decreases. Is it clear? Yes, Suleiman. Yes.
Ma'am, can you repeat that point?
That density. Just a second.
Okay, ma'am.
Yes. What I was saying is that the density in this state is actually decreased to 100,000, the density of air. Okay. I hope you know when we are saying 100, we mean 1/100. Okay.
Yes, ma'am. I was noting. Yeah, ma'am.
Yeah. Of air. Okay. At very low temperatures. Okay. Very low temperatures. You can also call them super low temperatures. That is why we operate superconductors at this temperature. Okay.
Yes, ma'am.